This is our max class. In the previous class, we have seen some examples of exercise 2.6. Today, in this video, we are going to learn how to do the solution of remaining examples and exercise 2.6 problems. First, let us recall some important points of an arithmetic progression. In an AP, the general form is A plus D, A plus 2D and so on. Next we see the nth term of an AP is Tn is equal to A plus n minus 1 into D. Here A is first term, D is common difference and n is a nth term. The next point, number of terms of an AP is equal to L minus A divided by D plus 1. Here L is a last term, A is a first term, D is a common difference. The three consecutive terms of an AP is A minus D, A plus D. Here the common difference is D. Then the first four consecutive terms of an AP is A minus 3D, A minus D, A plus D and A plus 3D. Here the common difference is 2D. Next we see some important points of an arithmetic series. The general form of the arithmetic series is A plus D plus A plus 2D up to nth term A plus n minus 1 into D. Sum to n terms of an AP, that is Sn is equal to n by 2 into 2A plus n minus 1 into D. Then another formula, Sn is equal to n by 2 into A plus L. In the question, when first term and common difference given means use this formula and find the sum of n terms, or in the question first term and last term are given means using this formula find the sum of n terms. These are the important points to remember of this exercise. Let us see the example 2.38 of exercise 2.6. See the question. The house of a street are numbered from 1 to 49. Senthil's house is numbered such that sum of numbers of the houses prior to Senthil's house is equal to sum of numbers of the houses following Senthil's house. Find the Senthil's house number. In this question, what is the given? In a street there are 1 to 49 houses are there. In this, in between Senthil's house are available. Here you have to find the Senthil's house number. Let us see this diagram. See, these are the houses in a road. There are 1 to 49 houses are there. So here in between Senthil's house is there. So this house number we have to find. So let us assume this house number be X. Then means before that house number is X minus 1 and after the Senthil house number is X plus 1. Next important given in the question. The sum of the numbers of the houses prior to Senthil's house is equal to sum of the numbers of the houses following Senthil's house. It means sum of the houses prior the Senthil's house is equal to sum of the houses after the Senthil's house. This both sums are equal. From this given, we have to find the Senthil's house number. Let us do the solution. Let Senthil's house number be x, given that before Senthil house sum is 1 plus 2 plus 3 up to x minus 1 is equal to sum of after Senthil houses x plus 1 plus x plus 2 up to 49. In this, for finding sum, we need from the first number, because here x is an unknown value. So, you have to change the after equal series will be 1 plus 2 plus 3 up to 49 minus 1 plus 2 plus 3 up to x. Therefore, x minus 1. So, this series starts from 1. Therefore, number of terms also x minus 1 and last term also x minus 1. Therefore, x minus 1 is equal to 2. Here also the series starts from 1. So, last term and number of term also 49. So, S49 minus Sx, that is, you bring the x term before the equal. So, Sx minus 1 plus Sx is equal to S49. Now, you have to apply the Sn formula. Here we know the first term and last term. So, Sn is equal to n by 2 into a plus l. That is, Sx minus 1 plus Sx is equal to S49. That is, here n is x minus 1, a is 1. Therefore, x minus 1 by 2 into a 1 plus last number also x minus 1 plus here n is x, so x by 2 into a 1 plus last number x, which is equal to n by 2, 49 by 2 into 1 plus 49. Now, you have to simplify this. That is, here plus 1 minus 1 cancel. Then you can written x minus 1 by 2 into x plus x by 2 into 1 plus x is equal to 49 by 2 into 50. For cancelling this by 2 table, 1 2 is to 25 2s are 50. Now, you have to multiply this, and this means we get x into x, x squared, minus 1 into x, minus x, x into x plus x, x into x plus x squared. Here 2 is common denominator. So, you take commonly one time, that is 2 is equal to. Now, you have to multiply 49 into 25 means we get 1225, which is equal to, here minus x plus x cancel, then x squared plus x squared we get 2x squared by 2 is equal to 1225. Cancelling this 2, then we get x squared is equal to 1225. Therefore, x is equal to square root of 1225. That is, x is equal to plus or minus 35. But house number never be negative. Therefore, x is equal to plus 35 is the answer. the value of x is plus 35. Hence, the Senthil's house number is equal to 35. This is the answer for this question. Let us see the next example 2.39. See the question. The sum of first n, 2n and 3n terms of an AP or S1, S2 and S3 respectively. Prove that S3 is equal to 3 into S2 minus S1. In this question, the sum of first 3 terms of an AP are given. We have to prove the given term. Let us do the solution. First you take down and write the given S1, sum of S1 have n terms. Therefore, you have to apply the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. Because here number of terms only given, last term is not given. Therefore, you have to apply this formula. Therefore, S1 is equal to, in the question they are given S1 has n terms. Therefore, S1 is equal to, here number of terms n by 2 into 2a plus n minus 1 into d. Now, you have to multiply this d and remove the bracket, means we get n by 2 into 2a plus nd minus d. This one you keep number 1. Then next you have to write the terms of S2. That is S2 is equal to, S2 contains 2n terms. Therefore, here value of n is 2n by 2 into 2a plus 2n minus 1 into d. It can be written as 2n by 2 into 2a plus 2nd minus d. Let us assume this second equation. Then next given S3 is equal to, number of terms of S3 is 3n terms. Therefore, 3n by 2 into 2a plus 3n minus 1 into d. Now you have to multiply this, means we 3n by 2 into 2a plus 3nd minus d. This is, let us assume this one number 3. Now you take down and write the to prove S3. S3 is equal to 3 into S2 minus S1. First you write left hand side. LHS S3 is equal to, write this third equation, that is 3n by 2 into 2a plus 3n d minus d. This one you take left hand side answer, that is. Next you take right hand side, that is RHS. Here RHS is 3 into S2 minus S1. From first and second equation we have 3 into S2, 2n by 2 into 2a plus 2nd minus d minus of S1 n by 2 into 2a plus nd minus d. Now here n by 2 and n by 2 is common, so you take out n by 2 means we get 3n by 2 into, now you have to multiply this 2 inside the bracket term means we get 4a plus 4nd minus 2d. Now here you have to multiply the minus sign inside the bracket term means we get minus 2a minus nd minus into minus plus d. It can be written as 3n by 2 into, now you have to simplify the like terms. 4a minus 2a we have 2a, then 4nd minus nd we have plus 3nd, then minus 2d plus d we have minus 1d. This is the answer for right hand side. So let us assume this number 2. From 1 and 2 we get S3 is equal to 3 into S2 minus S1. That is, left hand side is equal to right hand side. Hence proved. Now let us start to do the exercise problems, that is exercise 2.6 fifth sum. See the question. The 104th term and 4th term of an AP are 125 and 0. Find the sum of the first 35 terms. In this question, T104 and T4 values are given. Here we have to find the value of S35. Then means first you have to find the A value and D value, that is first term and common difference. Let us do the solution. First you take down and write the given. In an AP, T104 is equal to 125. T104 is equal to 125. Now you have to apply the general term of T104, that is A plus 103D is equal to 125. Let us assume this first equation. Now you have to write the next given, that is T4 is equal to 0. The general term of T4 is A plus 3D is equal to 0. Let us assume this second equation. Now we have two equations. So you have to eliminate these two equations and find the value of A and D. See, first equation, A plus 103D is equal to 125, and second equation, A plus 3D is equal to 0. Now you have to subtract these two equations, means we have to eliminate the A term. So you change the sign, subtract. So you have to change the sign. Then we get plus A minus A cancel and get 0. Then 103 minus 3 we have 100D is equal to 125 minus 0 we have 125. Therefore D is equal to 125 by 100. Now you have to cancel this by 5 table, means we get 25, 5s are 125, 20 5s are 100. Then again cancel by 5 table. 5 5s are 25. 4 5s are 20. Therefore, the value of D is 5 by 4. Hence, the value of D is equal to 5 by 4. Now, you have to substitute this value in the second equation, means we get the value of A. That is, first you take down and write the second equation, that is A plus 3D is equal to 0. Here A plus 3 into D is 5 by 4 is equal to 0. Therefore, A plus 3 into 5, 15 by 4 is equal to 0. Hence, the value of A is equal to minus 15 by 4. This is the value of A. Next, we have to find the sum of first 35 terms, that is S35. For this, we have to apply the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. So, S35 is equal to, here n is 35, 35 by 2 into 2 into, here a is minus 15 by 4 plus n minus 1, 35 minus 1, 34 into, here d is 5 by 4. Now, you have to simplify this, means we get 35 by 2 into, here 2 and 4 is cancelling by 2 table, minus 15 by 2 plus, for cancelling this 2 table we get 17 into 5, 85 by 2. Now, you have to simplify this, means we get 35 by 2 into, here 2 is common factor. So, minus 15 plus 85 we have 70. So, 70 by 2. Now, you have to cancel this by 2 table. 1 2 is 2. 3 2s are 6. Remainder 1. 5 2s are 10. So, we get 35 into 35 by 2. So, S35 is equal to, now you have to simplify this, means we get, that is 35 into 35, 1225 by 2. Cancelling this by 2 table, 6 2s are 12. 1 2 is 2, 2 2s are 4, remainder 1, 10, 5 2s are 10. Hence, the value of S35 is equal to 612.5. This is the answer for this question. Let us do the next sum, that is question number 6. See the question. Find the sum of all odd positive integers less than 450. Here we have to find the sum of odd positive integers which is below 450. Let us do the solution. First you take down and write the given question series, that is odd positive integers start from the number 1. The sum of all positive integer less than 450 is odd positive integers. All odd positive integers start from less than 450. Therefore, the series is 1 plus next positive integer 3, next odd positive integer 3, then plus 5 up to less than 450. So, positive odd number is 449. Now, we have to find the sum of this series. Here we know that A is equal to 1 and D is equal to T2 minus T1, that is 3 minus 1, 2, and L is equal to 449. For finding Sn, we need n. So, first you have to find the value of n. Then means which formula you have to apply? Yes, n is equal to last term minus first term by common difference plus 1. So, here n is equal to last term 449 minus 1 by d, here d is 2 plus 1. Now, you have to simplify this, means we get 448 by 2 plus 1. Cancelling this by 2 table, 1 2 is 2, 2 2s are 4, 2 2s are 4, 4 2s are 8. Therefore, n is equal to 224 plus 1, that is 225. Here, the value of n is 225. Now, you have to apply the Sn formula. Here we know the last term. So, you have to use the Sn formula. Sn is equal to n by 2 into A plus L. Here S225 is equal to 225 by 2 into, here A is 1 plus L is 449. Now you have to simplify this, means we get 225 by 2 into 450. Cancelling this by 2 table, 1 2 is 2, 2 2s are 4, 2 2s are 4, remainder 1, 5 2s are 10. Therefore, now you have to multiply this 225 into 225, we get 50,625. Hence, the answer is the sum of all odd positive integers less than 450 is 50,625. This is the answer for this question. Now, let us do the next sum, that is question number 7. See the question. Find the sum of all natural numbers between 602 and 902 which are not divisible by 4. Here we have to find the sum of all natural numbers between, then means we have to find from 603 up to 901. Here they given which are not divisible by 4. These two things are very important. In this question, we have to find the sum of natural number 603 to 901 which are not divisible by 4. Then means first you have to find sum of all natural number between this given number. Then next you have to find sum of all natural number between the given number which is divisible by 4. After that you have to subtract this 2 sum, means we get the answer for not divisible by 4. Let us do the solution. First step, we have to find the sum of all natural numbers between 602 and 902. It can be written as S n is equal to 603 plus 604 plus 605 up to plus 901. Here A is 603 and D is equal to 1 and L is equal to 901. For finding Sn, we need the value of n. So first you have to find the value of n. What is the formula? Yes, n is equal to last term minus first term by common difference plus 1. Here last term 901 minus 603 by 1 plus 1. Now you have to simplify this, means we get n is equal to 101 minus 603 is 298 plus 1. That is n is equal to 299. Therefore, sum of 299 terms is equal to, we have to apply the formula n by 2 into a plus l, because here we know the last term. So, here n is 299 by 2 into first term 603 plus last term 901. Now you have to simplify this, means we get 299 by 2 into, adding this two number we get 1504. Now you have to cancel this by 2 table. 1 2 is 2, 7 2s are 14, 5 2s are 10, 2 2s are 4. That is 299 into 752 is 2,24,848. That is, the value of S299 is equal to 2,24,848. This is the answer for total sum of the given number. Next, we have to find the sum of all natural number between 602 and 902 which are divisible by 4. That is, have the between numbers 603 plus 604 up to plus 901. From this we have to find the numbers which are divisible by 4. First number, let us see. You have to divide this number by 4, means we get the remainder. That is 603 divided by 4. 1 4 is 4, remainder 2. The next number 0. 5 4s are 20. Then take down the next number, that is 3. Hence here the remainder is 3. So for finding first number, you follow this rule, that is, from the divisor you have to subtract the remainder, that is 4 minus 3. After that, adding that answer the dividend, that is 603. It means 4 minus 3 we have 1, then add 603 plus 1 we have 604. Therefore, the first number which are divisible by the given series is 604. Then next number 604 plus 4 means we get 608. 608 plus 4 means we get 612. Then last number, likewise you have to find the last number, that is 901 divided by 4. See, 901 divided by 4. 2 4s are 8, remainder 1, 0. 2 4s are 8, remainder 2. Then next take down and write means we get 21. Then 5 4s are 20, remainder 1. For finding last number, you have to subtract the remainder from the dividend, that is 901 minus 1. You get last number, that is 901 minus 1, we have 900. Therefore, the last number 900. So, let us see 604 is exactly divisible by 4. Then last number 900 also exactly divisible by 4. Now you have to find the sum. Here A is equal to 604 and D is equal to plus 4. Then last number L is equal to 900. For finding Sn, here also we need the value of n. Therefore, n is equal to last number 900 minus first number 604 by common difference 4 plus 1. Now you have to subtract this, means n is equal to 900 minus 604, we have 296 by 4 plus 1. Now you have to cancel this by 4 table. 1 4 is 4, 7 4s are 28, remainder 1, 4 4s are 16. Therefore, n is equal to 74 plus 1, that is 75. Here the number of terms n is 75. By using this value, you have to find the sum of 75 terms, that is S75 is equal to n by 2. Here n is 75 by 2 into A plus L. Here A is 604 plus L is 900. Now you have to simplify this, means we get 75 by 2 into 604 plus 900, we get 1504. Now you have, for cancelling this by 2 table, we get 1 2 is 2, 7 2s are 14, remainder 1, 5 2s are 10, 2 2s are 4. Now you have to multiply this two number, we get 75 into 752 is 56,400. Therefore, sum of 75 terms is equal to 56,400. This is the sum of the number which are divisible by 4. But in the question they are asking which is not divisible by 4. Therefore, we have to subtract this 2 value, that is, take down and write the first value 2,24,848 minus 56,400. These two values we have to subtract, means we get sum of not divisible by 4, that is Sn is equal to 16,08,448. Now you have to take down and write the answer. Hence, the sum of numbers between 603 to 902, which is which is not divisible by 4 is Sn is equal to 16,848. 16,08,448. This is the answer for this question.